Hello and welcome to STEM Tutors. Today we are going to be going over a physics problem, the Tarzan physics problem. And let me explain exactly what's going on here. So here we have Tarzan, and Tarzan's going to be swinging on this vine. Once he reaches this point, he will slide on the grass for this distance. And all the knowns for this problem are given here on the left side. His mass is 75 kilograms. The length of the rope is 8 meters. 20 degrees is the angle between the rope and the horizontal. And he slides a distance of 15 meters. And as always, gravity is constant at 9.81 meters per second squared. So what we're trying to find in this problem is the friction force on Tarzan once he starts sliding. What is the force of friction along this path? So how should we start this problem? Well, the first thing I look at is I notice that Tarzan is starting out with some potential energy because he's starting off of a cliff. So we can look at this problem in terms of energy. So our energy equations are the following. We have potential energy, and all this potential energy is going to convert into kinetic energy because he will be on the ground. Is going to be equal to kinetic energy. So we have mass times gravity times height is equal to 1/2 mass velocity squared. Now since the mass in the beginning is equal to the mass at the end of this whole path, we can actually divide both sides by mass and leave us with a simpler equation to work with. Okay. So now the question here is, what do we have that is known? We have G. We have, actually that's the only thing we have. We have G. We don't know the initial velocity, and we actually do not know this height from the cliff. But if we're able to find out the height from this cliff, then we'll be able to find out what velocity he will have at this point, at the starting point. So some things to assume. When Tarzan reaches this point down below, he will be at length L, or the vine will continue being at length L. And let's say we want this to be h, that's our height, and we can draw a line horizontal. Line horizontal. And we notice that this gives us a right triangle here. And let's label this side of the triangle. Let's label the opposite side of this triangle as opposite, just like that. So let's write an equation of h in terms of all the lengths that we have known. So we see that h is equal to the length of the rope minus the opposite of the triangle. So now the question becomes, how do we find the opposite? We use some trigonometry. We use SOHCAHTOA. SOHCAHTOA, right? SOHCAHTOA. In this case, we are going to be using the sine part of SOHCAHTOA. We're going to be using the sine part of SOHCAHTOA in order to find this opposite length. So that tells us the sine of angle the sine of theta is equal to the opposite over the hypotenuse, and now we just plug in what we know. So here, sine of angle, the angle we have here is 20. The opposite is unknown, leave that as. The hypotenuse is L. L in this case is 8 meters. And then we can do some algebra, moving the 8 to the other side. 20 is equal to opposite. So after plugging this into a calculator, we get that the opposite length of the triangle is 2.74 meters, since our units are in meters. That is the length of the opposite. Now that we have the opposite, we can go back into our original equation and solve for h, the height of the cliff. So h equals 8, length of the rope minus 2.74, and that gives us h to be 3.226 meters. So now that we have the height, we can go all the way back to our energy equation to find out the velocity, the initial velocity of this path. So let me move some things out of the way. Okay. So here, now that we know our height, we can go into our energy equation and plug it in as so. We have 9.81 as our gravity, our height 5.26, equal to 1/2 velocity squared. Velocity squared to be 103. And to get the velocity, we just square root both sides. So that tells us the velocity is 10.14, and let's round up, 10.15 meters per second squared. So now we know the initial velocity of Tarzan in this path down here at the grass. So the next step we can do is use our kinematic equations to actually look at the rate of deceleration, right? And the reason why we want to know the rate of deceleration is because of this formula right here, because F equals ma. If we know the mass, the only thing we need to know for the force, in this case friction force, the only thing we need to know for friction force, if we have the mass of Tarzan, is the acceleration due to friction on the grass. And like we said, we're going to use our kinematic equations. In this case, we're going to use velocity. We're going to use velocity squared equal to velocity squared plus 2AD. And in this case, this is going to be final velocity. And this is initial velocity. And from there, we just plug in our values and solve for acceleration. So the final velocity at this point is 0 because Tarzan stops at this point. So we have 0 squared. The initial velocity we got from before as 10.14 15 squared. We have 2. A, we do not know. D, we do have 15 meters. A. So then we square 10.15, put it to the other side. That should give us negative 103 equal to 30A. We should get that our acceleration is negative 3.43 meters per second squared. Now notice in this case it's negative, which makes sense because this acceleration is slowing us down, right? Had this been positive, that would mean that Tarzan would be speeding up. So it's good that the negative checks out. Here our mass is 75, acceleration we found, negative 3.43, which gives us our answer to be find both sides, we get our answer as negative 257.25 newtons, and that solves our problem.